Okay, good morning. So we are going to look at this new set of problems from today. So this first one is actually from yesterday. So this is all about Kirchhoff's current and voltage rules being put together, right? So what we're going to do here is we're going to basically do the same thing. We're going to make our two loops. So I'm going to take a pen and we're going to just draw the loops in any direction we want. I just draw them in the same direction. So I'm going to go clockwise for both. All right. So when we trace, we'll do the one on the right side first, right? So we get our 7 volts. So we have 7 volts. We gained 7 volts. That's our voltage gain. Actually, I want to write just 7, okay? And then we're going to spend voltage at this 5 ohm resistor. All right, so we're going to spend voltage. Now, we don't know what the voltage is, but we know that V equals IR from Ohm's law. So we're going to call this, instead of V, we're going to say I, and we'll call this current in this branch, and call this one I1. Okay, so 7 times, or 7 minus I1 times, as V equals I times R times 5. Okay. And if we keep tracing around, we get back to the battery, and we know that the entire voltage, the voltage increase, which is the 7, must equal the voltage drop, which is going to be whatever I times 5 is. So we can say this is equal to 0. And then if we arrange, we would add the 5I to the other side, and then solve for I, and we end up with I1, okay, is 7 over 5, or 1.4 amps. Okay, we're going to do the same thing now for the other side. So we'll change our color up. Let's make this one red. All right, so again, we're going to start from here. Okay, all right, so we start with our 7 volts. Okay, and then our current, we're going to call this current. All right. We'll call this one I2. All right, so now we gain the 7 volts. Again, I don't actually want to write the V, my bad. Okay, so we gained our 7 volts, and then we're going to spend our voltage in these 2 resistors. So again, we don't know what V is, but we can say V equals IR, so that's going to be 3I2 and 4I2. They both get the same current running through them. And again, when we get back to the beginning, we know Kirchoff's voltage rule says the voltage gained, which is the positive value, must equal the voltage lost, which is the sum of the negative values, and that's going to equal 0 again. All right. So if we add the negative 3I2 and the negative 4I2, that gets us negative 7I2. If we bring it to the other side, we get 7 equals 7 times I2. When we solve for I2, we get 1. Okay. So that's the current in each branch. The current in the right branch is 1.4. The current in the left branch is 1. Right. Then it asks, what is the voltage that each item is going to receive? How many volts? Well, for the right-hand side, we don't have to do any math for it. We know that the voltage gain must be equal to the voltage lost. So this side on the right-hand side is going to get the full 7 volts. So how many volts would this get? All right, 7. Okay. On the left-hand side, all right, the voltage is not going to be equal because there's 2 different resistors and they have different values. But we can just work backwards, right? We know that to find voltage, it's V equals I times R. Well, now that we know I, 1 on the left-hand side, and we know their resistance values, 4 ohms and 3 ohms, to find V, we would just do I times each R. So V equals IR on this side ends up being 4 volts. And if V equals IR on the side, it becomes 3 volts. And if you add them together, 4 plus 3 is 7. So we spent 7 volts on the left side of this left branch, and we gained 7 volts from this middle battery. Okay. So that's how we solve the question, the first question. All right, let's look at this one. So what is the value for the voltage drop or the negative voltage for VA and VB? So here we're not actually gonna, we're gonna again do our little loops. Okay, so I'm gonna draw both loops going clockwise. And again, we'll do them in two different colors just so you can tell the difference. Okay. So let's look at the one in red first. So we start with 9 volts. That's our voltage gain. We gain 9 volts from the battery. It starts gains 9 volts. When we go around this first loop, we spend 2 volts here. Then we're going to spend volts at VA. And then we come down to here and we're spending 1 volt here. And again, Kirchoff's junction law with voltage says that the voltage gained, which is 9, must be equal to all of these things that we lost. Okay? Or you can say it's the same thing as saying it's equal to 0. Voltage gain must be equal to voltage loss, meaning both sides add up together to give you 0. So now if we solve for VA, 9 minus 2 is 7, minus 1 is 6. When you bring the VA to the other side, we find out that VA is 6 volts. Okay, same thing now for this one. All right, we start with, well, actually, we could do this in 2 different ways. Now that we know VA, okay, we can kind of trace this around. Okay, so if we do that, all right, we would end up with, we're spending, actually change the color again. It's actually, okay, there's 2 ways you can actually do this one. We'll show you both ways. So first we'll actually do this little loop. So we can say this. So we start here, we're losing 3 volts, okay? Then we're going to lose volts at VB. We're going to lose volts at the 2. So 3 VB2. Here's where it's a little odd. This part is going up here, right? Because if we follow this circle, it's a clockwise circle. So here we're actually going up. Notice we're going against the arrow. We're going against the flow of the current. So since we're going against it, instead of spending this voltage, we're actually going to gain this voltage. So plus VA, and we know VA is 6, so I'm just going to write VA for now. And then we get back to the beginning, and then we know, again, all the voltage going in equals the voltage going out, so this is 0. All right, so if we bring VB to their side by adding it, we would get VB equals, and now let's plug all of our numbers in. Okay, -3 plus -2 is -5. Okay, and then plus VA, well, we found that VA from before is 6, so that means VB is 1 volt. Okay. There's another way you could do this one. If you didn't like to do it that way, we could do it like this. We could make the loop this giant outside thing. Okay, so now we're going to just look at the voltage guys on the outside. So same thing, we start with 9. We lose 2. We lose 3. There's VB. We lose 2. And we lose 1. And again, that has to be equal to 0. So let's figure this out. 9 minus 2 is 7. 7 minus 3 is 4. Okay. 4 minus 2 is 2, and 2 minus 1 is 1. Okay. So we have negative VB equals 1, or I'm sorry, negative VB plus 1 equals 0. All right, so we bring the VB to the other side, we find out that VB is 1 volt. So when you do this problem, you can do it in 2 ways. We can either do the 2 inner loops, red and green, or you can do the red loop and the blue loop. Okay, either way, you'll get the right answer.